All right, today we're going to be talking about arc length for our notes for worksheet 2. So first we have to define what an arc is. So I'm going to go ahead and switch to typing here. So an arc is a piece or portion of a circle. A major arc is an arc that is larger than 180. And then a minor arc is an arc that is smaller than 180. So major arcs are named with 3 letters. So let's say, let me highlight here. Let's say I want to name this major arc that would be larger than 180. I would use EDF or FDE, whatever direction you want to go, but I would have arc EDF like so. If I wanted a minor arc, so let's say we want arc EF, I know it's smaller than 180 if I name it with only 2 letters. So arc EF or FE, whichever direction. A semicircle is an arc that is exactly 180 degrees. Oh. Oops. It can be 2 or 3 letters, whatever your preference is for that one. Since it kind of fits into both major and minor, it can be 2 or 3 letters when you name it. So if we are looking at this picture over here on the right, that would be, you could do like HMG, or you could do just HG or GH. Arc length. So we know what an arc and then the different subtypes of arcs are. Arc length is specifically a piece of your circumference. And then arc angle is the portion, angle, portion, out. What do I want to say there? All right, we're going to say piece or portion of total angle sum. Okay, so determine arc measure. So arc measure and arc length are different. When it is talking about arc measure, we want the angle. And if it said arc length, that's when we would take into account the circumference as well. So the measure of CE, I know that's a minor arc because it's only using 2 letters, and it looks like I just need to do 53 plus 34, so that'd be 87 degrees. EF would be this piece, and I know that CF is a diameter, so this whole semicircle here would have to be 180. So if I do 180 minus 87, I should get 93 degrees there. ECK, that's going to be a major arc. ECK would be here. I do know on this second half of my semicircle that all 3 of these are congruent since they're all marked as such. So I'd have 60, 60, and 60. So I need 87 plus 120 is 207. And then DFC. DFC would be everything except for this 53. So 360 minus 53 should be 307. All right, part B over here, measure of DF, we have a new figure. So let's try to puzzle piece this together. It is saying that from F to E, it's 126, which if I take 180 minus 126, let's do that, 180 minus 126 is 54 here. And then it's saying these 2 segments are the same. So if I have 180 minus 112, that's 68. So each of these smaller portions would be 68, which is going to make this little portion, 126 minus 68, is 58. So now I know all my little pieces. That'll help me answer my questions. So DF here would be 68 degrees. FR is 58. EC, where's that? EC is 54. And DFE would be these added together. So 68, 58, and 68 is 194. Okay, moving on. Central angles and arc measurement. So our central angle, if the whole thing is 360, if it's an equilateral triangle in the middle, we would be dividing that by 3 for 3 sides. So 360 divided by 3 is 120. Okay, here I would divide by 4. 360 divided by 4 would give me 90. Here I'd divide by 5. 360 divided by 5 is 72, I believe. And then this one would be divided by 6, so 60 degrees. Okay, ABC, angle ABC is a central angle. Central angle is equal to the intercepted arc measure. So if you have an arc measure on the outside, that's going to be the same as your central angle, and vice versa. And then here we have 4 congruent arcs, so we have 4 congruent central angles. And then a diameter is a central angle of 180. That's the arc should also be 180 if they're asking for the arc measure. So we have to remember also that arc measure and arc length are 2 different things. Up here, I'm going to add divided by the number of sides for regular figures. So we were assuming on these 4 that that they were regular, meaning their side lengths were the same length. Okay, number 2, determine the missing information. Given circle B with EC as a diameter, we want to find arc AC. So if I know that this is a diameter and I have 39 here, that means this is also 39 because they've marked these as congruent for us. And then I know that this one is 70. So AC is 39 degrees, AE, and it has to be the minor arc since it's only 2 letters. I would do 180 minus 39 to get 141. EK here, I would do 180 minus 39 and 70 is 71. And then measure of angle KBD. Where's that? KBD is right here, and we've already labeled that as 39 degrees. Given concentric circles, meaning one is inside of the other, they share a center, with measure of arc GH34 and measure of angle AGJB to be 90. So those two are labeled for us. So it wants us to find HB here. So I know that this piece is 90. And then straight across vertical angles are the same, so this would also be 90. So if I want to find this piece, I could do 180 minus 90 minus 34, which will give us 56. So 90 plus 56 is 146. Okay, AJH. AJH would be right here. So if its arc measure is 56, that means the angle is also 56 degrees. LFK, so that's a major arc, LFK here, is everything minus 90 minus 56. So I'll do 360 minus 90 and 56 to get 214. And then IK is the last one. So IK, if its angle is 90 here, then this is also 90. Okay, these two circles would have different arc lengths because they have different radii, but their arc measures are the same since it's the same portion out of 360. Number 3 here, given a regular hexagon, determine the missing information. So measure of angle ATB would be here. Okay, so since it's a regular hexagon, I can take 360 divided by 6 to get 60 for all of my central angles. Measure of DTB, let's find that, DTB would be here, so 2 of them would be 120. Measure of AC, let's highlight that, would again be 120 since we're talking about 2 of those central angles, 2 of those segments. ECA, looks like we would just want to subtract 120, so 240. AEB, would be everything except for 60, so we'll say 300 degrees. And it is asking for the full angle. I did the arc length, but the full angle, actually, I think I just need to back it up. I was thinking of arc length. So here, AEB is this angle. But if I know that this is 60, 60, 60 here for this equilateral triangle, so for this triangle, they're all 60. So that means for our bigger triangle here, I have a 30, 60, 90. So it is 30 degrees. If AB equals 5 centimeters, so let's see, then what is TB? So this is 5. Where is TB? It was an equilateral triangle, so they should all be 5 centimeters. And then if AB equals 5, what is EA? EA. So we know that this is 6 and 6. Or here, let's use our 30, 60, 90. I know that this is 6, so that would make my hypotenuse 12. That's going to make my, 5. So 5 and 10. 5 here, 10 here. This is going to be 5 root 3. Okay, so 5 root 3 centimeters on that one, since this was a 30, 60, 90. All right, so we will now move on to our worksheet 3 notes.